chlor-alkali process. By the chlor-alkali process, you are obtaining three compounds, namely sodium hydroxide solution, chlorine gas, and hydrogen gas. So, majority we are using these three compounds for producing different salts and in different sectors. So that is the importance of chlor-alkali process. Here, major reactant is in this, that is NaCl. Clear? So now we are looking for other important salts in the sector, right? So what are the other important salts we are obtaining from NaOH or maybe from NaCl, directly or indirectly? NaOH is obtained by the electrolysis process NaCl. So that is the reason to say more important compound. NaCl is more important compound. So now we are looking for preparation of a important salt, that is bleaching powder. So do you know for what purpose we are using these bleaching in our regular life? Do you have importance for this bleaching powder? Yes, that is disinfecting cleaner. Maybe your surface or maybe the water, right? So that preparation of bleaching powder involved, right? Involved action of chlorine on dry slacker lime. So what is dry slacker lime? Calcium hydroxide, lime water. When you dry that lime water, that means decreasing the water content in that aqueous solution. What happens? It will be remained as powder. That dried saccharine lime will be treated with chlorine gas. So that supplying chlorine gas to this, you are producing now composition CaOCl2. CaOCl2 that you are producing called bleaching powder. So this is bleaching powder formula here. CaOCl2. Chemically, it was named as calcioxychloride. Calcioxychloride or calcium oxychloride. That is called as bleaching powder. So CaOH2 plus Cl2 gas reaction producing CaOCl2 and the water. Then by drying these, right, decreasing the percentage of water, right, then you are able to get it calcioxychloride. Then immediately it will be packed into plastic bags to avoid that escaping of a chlorine gas from it. If you heat it, what happens? Again, the chlorine gas will be escaped from it, right? So that is the reason. Then here, what are the uses of bleaching powder? Right? So chemical name of bleaching powder is calcium oxychloride or calcium chlorohypochlorite. Chemical name calcium chlorohypochlorite is the name of a CaOCl2. Then here, what are the uses of bleaching powder here? Uses of bleaching powder, many are there. So mainly you need to remember at least these following four uses. What they are here? Bleaching used as oxidizing agent in industries. Oxidizing agent in industries. So it can supply oxygen gas or reducing agent. So that's why here oxidizing agent. Reducing the other is called oxidizing agent, right? So simply bleaching powder is used in a wood pulp. What? To remove the color of that substance, pulp, right? Then it can be converted into paper, right? So decolorizing agent. Simply it is also used as decolorizing agent in a textile, fabric industry, cotton, linen, whatever it may be, right? Then here it is used in a disinfection of a drinking water, sterilization process, right? For what reason we are using? Because it can be chlorine content. It can supply chlorine gas. So chlorine gas is used as disinfecting of drinking water. So that is the reason to add bleaching powder into the water. Chlorine gas. It can kill that invisible living organism present in the water, right? So that is the importance. Then here in manufacturing of insecticides and weedicides, chemicals, right? So that fertilizers production also can be used with this bleaching powder. Then here used as reagent in preparation of chloroform CHCl3 chloroform, right? So remember that chloroform chemical formula of chloroform also. So these are the uses of bleaching powder and production of bleaching powder. The next we are moving to another salt, that was namely here baking soda. What is baking soda actually? It is simply chemically baking soda formula is NaHCO3. What we use in food substances, right? For especially baking of cakes or production of bread. In them we are using that baking soda, right? So here baking soda preparation by using the sodium chloride solution that is treated by the ammonia and carbon dioxide gases, right? So sodium chloride solution, brine solution treated by the ammonium and carbon dioxide gases, CO2 mines, right? So here that can combine and produce ammonium chloride and sodium bicarbonate. So you are able to obtain ammonium chloride as byproduct here. That also we can use, we can collect it. So two products, byproduct. So major source is sodium bicarbonate used as baking soda. So baking soda common formula is NaHCO3. So that is chemically called as sodium bicarbonate. That sodium bicarbonate used in different ways in our day-to-day life. So here it is what used as antacid, basic in nature, mild basic in nature and non-corrosive. Mild basic and non-corrosive. So that's why sometimes that water, if you suffer from acidity, you will be advised to drink soda. That not market soda, that is liquid carbonic acid. That soda is carbonic acid. Here it is sodium bicarbonate, salt that can dissolve into the water and drinkable, right? Non-corrosive in nature. So it is used as antacid. It is used in the preparation of baking powder by adding citric acid. So its concentration will be decreased somewhat by treating with citric acid. Then used in the preparation of soda water in cold drinks to get carbonic acid, right? Then here it is used as fire extinguisher because it is gets heated producing carbon dioxide gases. That is fire extinguisher. That's why for the carbon dioxide production you are using this sodium bicarbonate. Baking soda used as mild antiseptic for what your infection areas on the skin, right? So just you need to prepare what a paste by using the soda, then apply near that. So it can be used as antiseptic solution, right? So these are the uses of baking soda. Next here, one more is there, that is washing soda. We are using for cleansing of your cloths, right? So this is chemically sodium carbonate. That sodium carbonate is prepared by using the baking soda only. Just if you are heating under using certain temperature and pressure, that recrystallization of sodium carbonate will give you washing soda. Crystallization means solidifying, right? So that recrystallization of baking soda will produce sodium carbonate called washing soda. So here sodium carbonate is combining with the just heated, it is just added by water molecules, then it is producing you sodium carbonate with 10 water molecules. This here 10 number indicating you water of crystallization. That water of crystallization we'll discuss later. Then here, what are the uses of washing soda here? Washing soda is used in manufacturing of detergents. It is able to produce froth by dissolving in water. So that's why here sodium carbonate is used in production of detergent soaps, used in removing permanent hardness of water. When we add this washing soda, that hardness of water will be decreased, lowered, right? So to remove the permanent hardness of water, we are using this sodium carbonate. Then it is used in manufacturing of glass, soap, and paper industries to cleansing or ice cleansing agent. Then it is one of the important component in production of borax powder or caustic soda. Caustic soda is nothing, washing soda only. Here borax powder, caustic soda is NaOH. Caustic soda is NaOH, right? Borax powder is that carom board powder, right? It is used in preserving the pulses. We can add as a powder. Suppose at your home, if you observe insects in your rice, right? You can add this borax powder only, right? Carom board powder that we can add into the pulse, any pulses, right? Rice or dals, whatever it may be, right? We can add that borax powder. Then it is used in a domestic purpose for cleansing of cloths or floors, right? So these are the uses of washing soda. The next salt is here, preparation of plaster of Paris. Preparation of plaster of Paris. Plaster of Paris is chemically called as POP, plaster of Paris, chemically called as hydrated calcium sulfate, right? So heating of gypsum at 373 degree Kelvin, it loses of water molecules partially to give plaster of Paris here. So gypsum formula is CaSO4 2H2O that will be removed by 1.5 water molecule from it. Then it will produce a salt with half water molecule, hemihydrate calcium sulfate. Hemihydrate calcium sulfate. So that is called as here POP. So when you dry it, again you are able to get a hard substance that we can call it as here gypsum. So both we are using in our daily life. Here simply this plaster of Paris is used in plastering of bones, fractured bones for supporting, right? The doctors uses a soft material to give support for your fractured bones that hardened when it was dried. That is, dried means removing of water from that composition. That will give you simply hemihydrated calcium sulfate, CaSO4 half H2O. That is here simply you obtain called POP, plaster of Paris, that will be used by the doctors, ortho specialists. They can use as a plaster for supporting the fractured bones. Not only this use, we can use plaster of Paris in many ways, that making of chalk pieces, right? In preparing of idols, preparing of that airtight packing, right? So in many ways we are using in a production of toys and statues, right? Here designing of fireproof materials, right? Fireproof fabrics, we are using this calcium sulfate with half water molecule, and decoration of your floors and ceilings, walls, etc., right? So on the walls, wall putty you are applying, that is only here gypsum, plaster of Paris, right? Added by water and dried, then you will get a hard substance, right? So here ice, here cement to delay its setting time. If you add that into the cement, it can be hardened. That is setting time, reducing the setting time. So easily it will be dried. So these are the uses of plaster of Paris. So after this we have another topic, right? So that is production of gypsum. By removing adding of 1.5 water molecule to the plaster of Paris, you are able to produce a material called CaSO4 2H2O. This is only gypsum. We can use these sheets, ice, water, ceiling, designing, right, at your home, right? So these are the importance of some chemical salts. So we are completed about chemical salts in our class, right? So it is theory topic, right? You need to learn or remind them, right? So uses of salts, and preparation of salts with equation important in your examination point of view, right? So I think somewhat doubtful how you feel about these salts. Is it okay? Okay, feel better, right? So next we are moving to the topic is called here activity number 14, that is crystallization of water. Crystallization of what? Salt, sorry. Crystallization of salt that able to give you some water molecules, that is called water of crystallization. Water of crystallization. So what number of water molecules contained or present in the salt called water of crystallization? Here simply suppose if you observe NaCl salt, what is available at your home? Is it looking dried or wet? How you can see that? How you are feeling? Is it as a dried salt or wet salt? Dried salt. It is what? Dried salt. That dried salt contain any water molecules in it? Water is present in that salt? Water is present in that salt? Yes, present. But you are unable to perceive that water molecules directly in the salt. So what are the required materials to observe that water of crystallization is hydrated copper sulfate. Hydrated copper sulfate color is blue color. It look like your salt crystals only, but green in blue in color. So blue color crystals you are collecting. So here to conduct this activity, few more required materials are there. They are here test tube, burner, water, then watch glass, etc. Then pair of tongs to hold your test tube while heating. So these are the required materials. So I am taking pair of tongs holding test tube. So like this you have to take it, right? So this is pair of tongs, boiling tube, holding with your hand as I shown on the screen. Then here use hydrated copper sulfate crystals, certain amount, drop into the boiling tube. So I am added that hydrated copper sulfate, blue colored solid crystals added into the boiling tube. Then slowly heat this solution, salt. So use Bunsen burner to heat up. So while you are heating, are there any changes in the color of salt? And did you see any formation of water droplets on the inner walls of your boiling tube? So while heating, you are able to see that turning of salt into white in color. See, blue colored salt changing into white crystallines. While it is turning, you are able to find out or locate a few water droplets formed on the surface of inner walls of your test tube. So how you get this water droplets on the surface of a boiling tube? This is because of the salt present in it, right? That vapor released from the blue colored salt. When the vapor lost from that means the water released from the blue colored salt will be turned into white in color. So that white crystals you are now collecting into the watch glass. So take that white crystals into the watch glass. Then what to do? You need to add a few drops of water. So when you add few drops of water into this white colored salt obtained by heating of hydrated copper sulfate, blue colored salt, then add a few drops of water into this. What happens by adding these water droplets into that? Observe slowly. So here see that salt is turning into blue color, reappeared again in its previous color, blue color. So reappearance of blue color is observed. So this is because of presence of water molecules. So blue color is observed due to what? This blue color due to what? Presence of water. So actually that CaSO4 is present with water molecules, that is 5H2O. So this number of water molecules present in the dried salt, so this number of water molecules is called as here water of crystallization. Water of crystallization. So this is the definition for the water of crystallization. Number of water molecules present in the dried salt is called water of crystallization. In the composition CaSO4 5H2O, that 5H2O representing the number of water molecules present in the dried salt, called water of crystallization. So it is about water of crystallization. That blue color of calcium sulfate is due to what? Water of crystallization or water molecules. If you remove that water molecules, it changes into white color. If you add water molecules into the dried white salt, then again it reappeared in a blue color. Right? So this is about water of crystallization. Right? So any confusion in conducting this activity? Did you got experience of laboratory activity here? Just give me your response. Lab activity experience, how to conduct that, what is water of crystallization, how do you decide, right? Everything is fine. Everything is fine. So this is about today's class. Are you clear about this third lesson or not? Just you have to think yourself. Why? Just turning the pages of your textbook. If there is any confusion, try to ask me. Just turn the pages. Now only turn your textbook pages. Come individually, page wise. Look at the topics. I may forget to explain any topic. Use your textbook, go through pages, find out missing topics or confusing topics, doubtful topics, then ask me. Look at each and every page of your textbook.